What if I told you one simple switch on your CNC machine can be the difference between fire, a burnt tool, collision symbol, a broken cutter, grimacing face, or a perfect mirror-like finish? Same machine, same program, same material. But one choice, coolant on or off, completely changes the result. So what's actually happening at the cutting zone? Look closer at your machining process. When the tool hits the material, gear friction increases. Thermometer temperature rises instantly. Chips start forming at high speed. Now here's the real question. White right pointing backhand index, where does all that heat go? White right pointing backhand index, what happens to the chips? White right pointing backhand index, and why do some parts come out perfect while others fail? This is where the coolant decision becomes critical. You've probably seen this happen: grimacing face, tool edges wearing out too fast. Pouting face, chips sticking to the cutter. Fire, smoke or burning smell during cutting. Chart with downward trend, poor surface finish. And sometimes, warning sign, the tool suddenly breaks mid-operation. You check everything: feed, speed, tool path, but the real issue. White right pointing backhand index, coolant strategy. Explanation: coolant on versus off. Droplet: when coolant is on, heavy check mark, heat is reduced instantly. Heavy check mark, chips are flushed away from cutting zone. Heavy check mark, tool life increases. Heavy check mark, surface finish improves. Heavy check mark, less friction is equal to smoother cutting. Coolant acts like a shield plus cleaner plus temperature controller. Fire: when coolant is off, heavy check mark, higher temperatures at cutting edge. Heavy check mark, chips may stick and recut. Heavy check mark, tool wear increases faster. Heavy check mark, risk of built-up edge, BUE. Heavy check mark, possible tool failure. But wait, coolant off is not always wrong. Scales twist, add depth and insight. There are situations where coolant off is actually better. High-speed machining, HSM. Materials sensitive to thermal shock, like some carbides. Dash symbol when using air blast or dry machining strategies. Why? Because sudden cooling plus high heat cycles is equal to collision symbol, micro cracks in the tool. So in some cases, white right pointing backhand index, dry machining gives better tool life. Electric light bulb solution, practical guidance. Here's how to decide. White heavy check mark, use coolant on when cutting steel or hard materials. Deep cuts or heavy loads. Chip evacuation is critical. Cross mark, consider coolant off, air blast when high-speed finishing. Aluminum machining with proper chip evacuation. Tools designed for dry cutting. Direct hit pro tip: always match coolant strategy with tool, material, and speed. Rocket real impact, why it matters. This one decision affects chart with upward trend, productivity, money back, tool cost. Direct hit accuracy. Sparkles, surface finish. Ignore it, and you are literally burning money with every cut. White down pointing backhand index. Now tell me, do you run your CNC mostly with coolant on or off? Speech balloon, comment coolant, and I'll share the best settings for your material. Thumbs up sign like this if you learned something new. Repeat button, share with someone who struggles with tool life. Push pin, follow for more CNC secrets that actually work. Chart with upward trend, productivity, money back, tool cost. Direct hit accuracy. Sparkles, surface finish. Ignore it, and you are literally burning money with every cut. White down pointing backhand index. Now tell me, do you run your CNC mostly with coolant on or off? Speech balloon, comment coolant, and I'll share the best settings for your material. Thumbs up sign like this if you learned something new. Repeat button share with someone who struggles with tool life. Pushpin follow for more CNC secrets that actually work.